1 billion kilometers from the sun, a planet wears a crown. A crown made not of gold or jewels, but of ice. Billions of fragments, each one orbiting in near perfect formation, creating the most beautiful structure in the solar system. This is Saturn. And tonight, we explore its rings. Saturn is the sixth planet from the Sun. It is a gas giant, roughly 9.5 times the diameter of Earth and 95 times its mass. Like Jupiter, it has no solid surface. Just an atmosphere of hydrogen and helium that grows denser and hotter the deeper you go, eventually transitioning into liquid and then metallic hydrogen. But no one thinks of Saturn for its atmosphere. They think of the rings. Saturn's rings are visible through even a small telescope. Galileo was the first to see them in 1610, though his telescope was too primitive to resolve their true shape. He thought Saturn had ears. Later observations revealed the truth. A vast, flat disk of material encircling the planet, thin and bright and utterly unlike anything else in the sky. The rings extend outward from Saturn for nearly 300,000 kilometers. That is roughly 3/4 of the distance from the Earth to the Moon. They are enormous. And yet, they are astonishingly thin. The typical thickness of the rings is only about 10 meters. Some sections are as thin as a few meters. To put this in perspective, if you shrank Saturn's rings down to the size of a football field, they would be about 10,000 times thinner than a sheet of paper. You could walk right through them and barely notice. They are the thinnest large structure in the known solar system. The rings are not a single solid sheet. They are made of billions of individual particles, each one orbiting Saturn independently. These particles range in size from tiny grains of dust to chunks of ice as large as houses. Most of them are made primarily of water ice, with some rocky material mixed in. They are bright and reflective, which is why the rings appear so vivid through a telescope. The particles are organized into thousands of individual ringlets, separated by gaps of varying widths. The most prominent gap, visible even through a small telescope, is called the Cassini division. It is about 4,800 kilometers wide, roughly the width of the continental United States. It appears dark because there is relatively little material in it, though it is not completely empty. The gaps in the rings are created and maintained by the gravitational influence of Saturn's moons. As moons orbit the planet, their gravity tugs on the ring particles, clearing out gaps and shaping the edges of the rings with extraordinary precision. The moon Mimas, for example, is responsible for the Cassini division. Ring particles that orbit at the same distance as the Cassini division have an orbital period that is exactly half of Mimas's orbital period. This 2-to-1 resonance causes Mimas to repeatedly tug on those particles at the same point in their orbit, gradually pulling them out of the gap. This process, called orbital resonance, is one of the most elegant mechanisms in planetary science. The intricate structure of Saturn's rings is not random. It is sculpted by gravity, shaped by the delicate gravitational dance between the planet and its moons. Some of Saturn's smallest moons play an outsized role in shaping the rings. These are called shepherd moons, and they orbit within or very close to the ring system itself. Pan is a tiny moon, only about 28 kilometers across, that orbits within the Anka Gap, a narrow clearing in the A ring. As Pan moves through the gap, its gravity sweeps ring particles aside, keeping the gap clean and well-defined. Without Pan, the gap would slowly fill in with drifting particles. Daphnis is even smaller, about 8 kilometers across, orbiting within the Keeler Gap near the outer edge of the A ring. Daphnis is so small that its gravity barely holds itself together, yet it creates visible waves in the ring material on either side of the gap. As Daphnis passes, it pulls on nearby particles, creating ripples that extend for dozens of kilometers, like the wake of a tiny boat in a vast ocean of ice. Prometheus and Pandora orbit on either side of the F ring, the thin, braided ring just outside the main ring system. Their gravitational influence confines the F ring, preventing it from spreading out. They are the shepherds, and the F ring is their flock. Without them, the F ring would dissipate into space. These shepherd moons are among the smallest objects in the solar system that have a measurable effect on their surroundings. They are tiny, irregular, battered by impacts, and utterly insignificant by most measures. And yet, they are responsible for some of the most delicate and beautiful structures in the rings. Size in the cosmos is not always a measure of importance. If you could somehow stand on the surface of one of Saturn's inner moons and look up, the view would be unlike anything in human experience. The rings would stretch across the sky from horizon to horizon, a vast, luminous arc of light. Depending on your position, you might see them edge on as a thin, bright line cutting across the sky. Or you might see them from above or below as a broad, glowing band with individual ringlets visible as fine lines of varying brightness. From the surface of Enceladus, the rings would appear as a brilliant white arch bisecting the sky. Saturn itself would dominate the view, an enormous pale sphere, its cloud bands visible to the naked eye, its shadow falling across the rings in a broad, dark wedge. From Titan, the view would be different. Titan's thick, hazy atmosphere would obscure most of the detail. Saturn would appear as a dim, blurry glow through the orange haze. The rings might not be visible at all from the surface. You would have to rise above the atmosphere to see them. From Mimas, just outside the main rings, Saturn would fill nearly half the sky. The rings would stretch out to the sides, impossibly thin, impossibly wide, glittering with reflected sunlight. And in the Cassini division, you might see stars shining through the gap, points of light visible between the ice. No human has ever seen these views. No camera has captured them from these angles. But the physics tells us exactly what they would look like. And someday, perhaps, a robotic explorer will send back images that confirm what we have long imagined. One of the most surprising discoveries about Saturn's rings is that they may be young. Saturn itself is about 4.5 billion years old, formed along with the rest of the solar system from the same collapsing cloud of gas and dust. But the rings may be far younger. Data from the Cassini spacecraft, which orbited Saturn from 2004 to 2017, suggests that the rings formed only about 100 to 200 million years ago. If this is true, the rings did not exist when the dinosaurs roamed Earth. They are a relatively recent addition to the solar system, a temporary ornament rather than a permanent feature. How do they form? The leading theory is that a moon, perhaps 100 kilometers across, wandered too close to Saturn and crossed the Roche limit, the distance at which tidal forces from the planet overcome the moon's own gravity and tear it apart. The moon was shredded into billions of fragments, which spread out into the flat disk we see today. Another possibility is that a comet struck one of Saturn's existing moons, shattering it and scattering the debris into orbit. Either way, the rings are the remains of a destroyed world. Every ice particle in Saturn's rings was once part of a larger body, a moon or a comet, that met a violent end. And the rings will not last forever. Saturn's gravity is slowly pulling the ring material inward, in a process sometimes called ring rain. Ice particles from the inner edge of the rings are drawn toward the planet by gravity, entering the atmosphere and evaporating. This process is removing material from the rings at a rate that, if it continues, will cause the rings to disappear entirely within the next 100 to 300 million years. We're living in a special time. Saturn has not always had its rings, and it will not always keep them. We happen to exist during the brief window, cosmically speaking, when Saturn wears its crown. Saturn has over 140 known moons. Most of them are small, irregular objects, likely captured asteroids or fragments of larger moons that were shattered by impacts. But a few stand out as worlds in their own right. Titan is the largest, bigger than the planet Mercury. It has a thick atmosphere of nitrogen and methane, thicker than Earth's. Beneath its orange haze, methane rain falls on landscapes of water ice. Lakes and seas of liquid methane at the surface. Titan is the only world other than Earth with stable liquid on its surface. It is one of the most fascinating places in the solar system, and a candidate for harboring exotic forms of life. Enceladus is small, only about 500 kilometers across, but it punches far above its weight in scientific importance. Geysers near its south pole spray water vapor and ice particles into space, fed by a subsurface ocean of liquid water. The plume material contains salt, organic molecules, and silica particles that suggest hydrothermal activity on the ocean floor. Enceladus may be the best place in the solar system to search for existing life beyond Earth. Mimas is one of the smaller round moons, about 400 kilometers across. Its most striking feature is a massive impact crater called Herschel, which is nearly a third the diameter of the moon itself. The crater gives Mimas an uncanny resemblance to the Death Star from science fiction. The impact that created Herschel must have come close to shattering Mimas entirely. Iapetus is a world of two faces. One hemisphere is as dark as coal. The other is as bright as snow. The dark material is thought to be dust swept up from a more distant, darker moon, coating one side of Iapetus as it orbits Saturn. The contrast between the two hemispheres is so extreme that when Giovanni Cassini first observed Iapetus in the 1670s, he could only see it on one side of its orbit. On the other side, the dark hemisphere faced Earth, and the moon seemed to disappear. Hyperion is the largest irregularly shaped moon in the solar system. It tumbles chaotically through space, its rotation axis shifting unpredictably over days and weeks. Its surface is covered with deep, sharp-edged craters that give it the appearance of a giant sponge. No one is entirely sure why Hyperion looks the way it does. Each of Saturn's moons is a world with its own story. And each one interacts with the rings in some way, shaping them, feeding them, or clearing gaps within them. The ring system is not a separate feature of Saturn. It is part of a larger ecosystem of moons and particles, all connected by gravity, all influencing each other in a slow, elegant dance. Close your eyes now and picture Saturn. Not as a dot of light in a telescope, but as it really is. An enormous, pale gold sphere wrapped in bands of cloud, crowned with rings that stretch hundreds of thousands of kilometers into space. Thin as paper, bright as snow, made of a billion fragments of a world that once was whole. The rings catch the sunlight and scatter it, glowing softly against the black of space. The shadows of the rings fall across the planet's surface, dark bands cutting across the clouds. And in the gaps between the ring lets the stars shine through, tiny points of light visible between the ice. It is, by any measure, the most beautiful sight in the solar system. And it will not last forever. But tonight it is there, spinning, shining, wearing its crown of ice.